Exponents may look advanced, but their basic meaning is simple. They show repeated multiplication. A root asks which number was multiplied by itself to produce a given value. GED questions may combine exponents with area, scientific notation, formulas, or algebra. In this lesson, you will read powers correctly, apply essential exponent rules, recognize perfect squares, and estimate roots when answers are not exact. In 5 cubed, 5 is the base, and 3 is the exponent. The expression means 5 times 5 times 5, which equals 125. It does not mean 5 times 3. Reading the notation correctly is the first control step. A power such as x squared follows the same idea, even when the base is a variable rather than a number. 4 squared equals 16 because 4 times 4 is 16. 4 cubed equals 64 because 4 times 4 times 4 is 64. Squares appear often in area formulas, while cubes appear in volume formulas. Keep the units consistent. A square with side 4 units has area 16 square units, and a cube with side 4 has volume 64 cubic units. 7 to the first power is 7, because only one factor appears. 7 to the 0 power is 1. The 0 power rule may feel unusual, but it keeps exponent patterns consistent. For example, 7 cubed divided by 7 cubed equals 7 to the 0 power and also equals 1. Remember that 0 to the 0 power is not treated as a standard value in basic GED work. 2 cubed times 2 to the 4th equals 2 to the 7th. You are combining 3 factors of 2 with 4 more factors of 2 for a total of 7. The bases must match for this shortcut. 3 squared times 5 squared cannot be combined by adding exponents because the bases are different, though it can be rewritten as 15 squared if useful. 5 to the 6th divided by 5 squared equals 5 to the 4th. 4 factors of 5 remain after 2 common factors cancel. If the subtraction produces 0, the result is 1. If it produces a negative exponent, the expression represents a reciprocal. But most basic GED questions focus on positive exponents and simple simplification. The expression open parentheses 3 squared close parentheses cubed means 3 squared multiplied by itself 3 times. That creates 6 factors of 3, so the result is 3 to the 6th. Do not add the exponents in this situation. Addition applies when multiplying separate powers with the same base. Multiplication applies when one exponent acts on another power. The square root of 81 is 9 because 9 squared equals 81. Perfect squares include 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Memorizing these common values saves time. The square root symbol usually asks for the principal or non-negative root unless an equation requires both positive and negative solutions. The square root of 50 is between 7 and 8 because 49 is 7 squared and 64 is 8 squared. Since 50 is only 1 above 49, the root is just above 7. You may not need an exact decimal. In multiple choice questions, bounding the root between 2 whole numbers can eliminate most answer choices immediately. In the expression 3 plus 2 squared times 5, calculate 2 squared first to get 4, then multiply 4 by 5 to get 20. Finally, add 3 for 23. A common wrong answer comes from working strictly left to right. Parentheses come first, then exponents followed by multiplication or division, and finally addition or subtraction. Exponent errors are usually predictable. 2 cubed is 8, not 6. When a negative sign is outside parentheses, negative 3 squared may mean the negative of 9, while open parentheses, negative 3 close parentheses squared equals positive 9. Read the grouping carefully. Also check whether the question asks for a power, a root, or a simplified expression rather than a decimal approximation. When unsure, rewrite a power as repeated multiplication. That step reveals whether exponents should be added, subtracted, or multiplied. For roots, work backward from familiar squares. Finish by estimating size and sign. Exponent rules are shortcuts, not separate facts. They are reliable because they describe what happens to repeated factors. and understanding that structure prevents most GED mistakes.